So we're going to integrate sine squared theta cosine squared theta from 0 to 2 pi. Now we need to work out what we're going to do with sine squared and cosine squared. Now integration by parts could be a good technique, or we could do something to try and simplify this term using trig identities. Now we've got sine squared and cosine squared. Now the famous trig identity that we all know with that one is sine squared theta plus cosine squared theta is 1. And now what we can do, we can simplify this by isolating one of these terms to get matching terms in this integral. So let's put cosine squared on its own. So therefore we subtract sine squared theta from both sides. So that's now the equivalent term. So now what we can do is this cosine squared, we can substitute this 1 minus sine squared. So let's just rewrite the integral from 0 to 2 pi sine squared theta. Now plug in this trig identity, sine squared theta d theta. Okay, now just multiply out the brackets, just FOIL that across, and then we go from 0 to 2 pi sine squared theta, and then sine squared times minus sine squared gives us minus sine to the 4 theta, and that's all one term within the integral. Okay, so now we've got these isolated, we can use the power reduction formula for integration for sine, which I've got written on here. So sine to the power of n theta gives us first integral n minus 1 over n, sine of n minus 2 theta d theta, and then we subtract this, which is not an integral, this is part of the answer, cosine theta sine to the power of n minus 1 theta divided by n. Now this works for all values of n, so all integers of n especially. So sine to the power of n, so here we've got a sine squared and a sine to the 4. So we can rewrite this integral here from 0 to 2 pi sine squared theta d theta minus the integral sine to the 4 theta d theta, and then apply the power reduction formula to each one of these integrals and then subtract this one from this one. Okay, let's go straight into sine squared theta. So power reduction formula, and in this case our n is 2 because we got sine squared. Now I'm just going to eliminate the range of integration from 0 to 2 pi. I'm just going to do the integral itself for now, just to use the power reduction formula. So that gives us n minus 1 over n. So for n equals 2, we've basically got 1/2, and then an integral sine of n minus 2. Well, n minus 2 is 0. So sine to the power of 0 will just become 1, and that's d theta. Okay, that's the first part, but now we've got this part here. So now that integral minus this term. So it's cosine theta sine. Now n minus 1, n is 2, so it's just sine. And that's all over n, which is 2. Okay, now this is a nice easy integral. That just gives us half of theta minus cosine theta sine theta over 2. And now we can simplify that a little bit more if we like. So we can go 1/2 theta minus cosine theta sine theta. So that's an integral of sine squared theta. But now we need sine to the 4 theta. So this looks like it's going to be a little bit more work. So let's just have a look. So power reduction formula when n equals 4. So n minus 1 over n. So that's going to give us 3/4 now. And then the integral sine to the n minus 2 theta. Well, n is 4, so that's going to give us sine squared theta d theta. And then minus this term here. Bearing in mind n is 4, so sine to the n minus 1 will give us sine cubed. So we're now going to subtract cosine. Let's just write that trig identity off the board. That's had its use already. So cosine theta sine cubed theta divided by n. Well, n is 4, so we just write a 4 there. Okay, so we've created another integral from our original integral, so it looks like we're getting nowhere. But sine squared theta d theta, we've already worked this out, and it's 1/2. So now all we need to do now is just plug in the 1/2 for this term, 1/2 theta minus cosine theta sine theta, and that will solve that integral because we've already done it. So 3/4 times 1/2 of theta minus cosine theta sine theta. So that's all of that term. And now we've still got to subtract this term here. Bearing in mind the 3/4 is only for the integral, not for this term. So minus cosine theta sine cubed theta over 4. Okay, let's see if we can simplify this up a little bit more, just try and clean this up a little bit. So now we get 3/8 theta minus cosine theta sine theta. That takes care of that. And then this one we can just bring down. Okay, now we've worked out this integral and we've worked out this integral. All we need to do now is subtract this one from this one, and that will give us our integral. So if I just box this off here into this box here, so now conveniently this integral here, I can just put an arrow here that's going to lead us to our answer, and just box this calculation here for the integral, and we'll just continue along here. So that keeps it nice and neat. So now all we need to do is calculate all of this subtracted from 0 to 2 pi. So put a nice bracket there. Sine squared theta was this one. So we've got 1/2 of theta minus cosine theta sine theta. And then we're going to subtract. Now, need to bracket this up here because we've got some minus signs and positive signs here, so we need to be careful when we do the calculation here. So I'm going to start bracketed again, and then we're going to have 3/8 theta minus cosine theta sine theta. So that keeps that as it's intended, and now we need to subtract this one, but still inside this bracket. So that's minus cosine theta sine cubed theta over 4. And now we can close this bracket, and then the big bracket, I only just fitted that in there, but we can see what's going on. So we've got this integral here, represented here, that's this one, and then subtracting this integral, which we calculated here, which we've subtracted here, and they're calculated from 0 to 2 pi. So now we can put these here in our brackets so you can see what's going on. Right, what can we do here? Well, we've got two very similar terms here, so maybe we could do the subtraction as intended on here. So we've got half of theta minus 3/8 of theta. So 1/2 minus 3/8 gives us 1/8, positive 1/8. So I'm going to continue with my full bracket here. So 1/8 of theta. And now we've got this term minus this term. So all in all, we're going to be left with a minus 1/2 of cosine theta and a plus 3/8 of cosine theta sine theta. So that's going to give us a minus 1/8 of cosine theta sine theta. Now that works well because we know here we've got theta minus cosine theta sine theta, and here if you factor out the 1/8 we've got theta minus cosine theta sine theta. So that takes care of that part of the calculation. Now the rest of this bracket here, we've got minus cosine theta sine cubed theta over 4, and we've got a minus here. So now what we can do is the minus and the minus obviously becomes a plus, and then we can add cosine theta sine cubed theta, and that's all over 4. And calculating from 0 to 2 pi, obviously that's the original question, that's what we need. Okay, so now all we need to do now is plug in 2 pi for all the thetas, and then plug in 0 for all the thetas, subtract the 2. So that will give us, so first bit first, theta, which is 2 pi, so we've got 2 pi over 8 minus 1/8 cosine 2 pi sine 2 pi, and then 2 pi in here, so plus cosine 2 pi sine cubed 2 pi, and then that's all over 4, and then we subtract from that, so put these in a little bracket here, and then we subtract from that 0 for all these values of theta. Well, that is just going to disappear because you're putting in a theta here, cosine theta sine theta, well sine theta, so sine 0 is 0, and same here, sine cubed 0 equals 0. So multiply any of these, and this one is 0, we'll just yield a 0. So therefore we're just going to be left with this term here. So I'm not going to bother writing out 0 for that one, we'll just leave that one as it is. Okay, 2 pi over 8, that just leaves us with pi over 4, and then cosine 2 pi sine 2 pi, while sine of 2 pi is equivalent to sine of 0, so this term is 0, so that means this will cancel out, and the same here, sine cubed of 2 pi will also be 0, so this will cancel out. So that just leaves us with pi over 4, and that is the answer to our integral. Pi over 4, sine squared theta cosine squared theta equals pi over 4. Okay.